Okay, so we would set up these problems is first of all I'm going to sketch a picture. So here's the woman and she's 60 kilograms and over here is the man and he's 90 kilograms and they're 10 meters apart. And we're trying to figure out how far the woman is from the center mass. So the center mass is probably going to be over here somewhere. Okay. So if I want to know how far she is from it, so I think I need to put the origin right here. So this is going to be 0. And so to figure out the center mass, of course, the equation would be, I'll say A and B. It's the mass of A times its position plus the mass of B times its position divided by the sum of the mass, which is MA plus MB. And so you can go ahead and calculate the position of the center of mass. Okay, now the next one. For this, they're standing on frictionless ice. So if he somehow moves 2 meters, then she's going to be moving too. So if they hold on the rope and the man pulls the rope, so he moves 2 meters. So he's going to be 2 meters closer to the center mass. So the center mass doesn't change its position because conservation momentum, the initial momentum 0, so the final momentum has to be 0. So whatever the man's position is relative to the center mass before, now he's going to be 2 meters closer. And the woman's also going to be closer. It's probably going to be more than, it's definitely going to be more than 2 meters though. So that center mass has not changed. So now I would recommend putting the man at the origin, and let's say this way is positive, because now you should know what this distance is, because up here you found this distance is center mass, and if you know the entire thing's 10, so if you take 10 minus that, that would give you his distance, then subtract 2, that would be how far this is now. And so that position has to be unchanged. So x center mass equals, let's see, let's see here. Well, we know what this distance is, so whatever that is, you'll know what that is. And then mass of A times the position of A plus the mass of B times its position, which is 0, divided by the total mass, mass of A plus mass of B. And it has to be equal to that same position because it hasn't changed. So I think that should work. All right, for the next one here, we have to figure out where the center mass is. So I would probably choose this to be the origin right there. And so find the x center mass by, let's call this A, B, and C. So it's going to be mass of A times its x coordinate, which would be 0, plus mass of B times its x coordinate, which is 0, plus mass of C times x coordinate, which is 2, divided by the total mass. So let's see, that's 11.5, 12.5, and 12.7, I believe, if I did that right. 2.5 plus 1.2, 3.7, yep, 12.7. There's also going to be a y center mass, so that's going to be mass of A, y position of A, which is 1, plus mass of B times y position of B, which is 0, plus mass of C times the y position of C, which is 0, divided by 12.7. Solve that. Center of mass of the system below lies in xy plane. Find the center of mass. Again, I would choose some place to be the origin. They went ahead and showed it right here. And so you kind of do the exact same thing as you did up there for that one. Okay, on the back side then, let's see. Consider the following mass distribution. 0. Okay, so for this one here, we know where the center mass should be at. So let's see here. It might be good to kind of sketch this. We have a mass here of 5 kilograms. And 1, 2, 3, 4. We got a mass here, 3 kilograms. And 1, 2, 3. We got a mass here, 4 kilograms. Then we have some other mass at 8 kilograms, so that the center mass will be right here. Well, I think it's going to have to be probably over here somewhere, right? Okay, so x center mass would be equal, how about we call this one A, B, C, and D. And we'll say that's the origin. So that would be, I think we said this was B, that's C. So that would be mass of C times its x position, which is 0. No, sorry, yeah, of C, sorry. Plus mass of B times its x position, which is 0, plus mass of D times its x position, which is 4, plus this one, the unknown one, so mass of A, which we know that it's 8 kilograms, times its x position, and that's the one we don't know, so x of A, all divided by the total mass, so 5 plus 3 is 8, that's 16, that's 20, so it's 20. And this has got to be equal to 0 here. So this is going to have to be equal to 0, and so you should be able to solve for this and figure out what xi is. Do the same thing for the y position. Everything's the same. They give you the coordinates, so you can figure out what it's supposed to be equal to, because you know the YCM is 0. Okay, for this next one, we're trying to find the center of mass of this distribution here. We have to choose some place for the origin. Let's say this is the origin. And so notice this is kind of cut up into little chunks. So how about I cut up this in a chunk as well? And let's just say this has a mass of M. This has a mass of M. This has a mass of M. And this has a mass of M. Further, let's say this is it says a uniform bar. So that mass of M, we can pretend it's right there. That would be at a quarter. Along the way, this mass here would be at 3/4. This mass here would be all the way out at 2, or it's going to be all the way out at 1 meter and up a quarter. And this mass of M here would be right here, which would be at 1 1/4, and 0 would be its coordinates. So you kind of do it like the other ones. You have to realize the coordinates here would be 0.25 and 0.5. And for this one here, it would be 0.75 and 0.5. And for this one here, it would be 1 and 0.25. And for this one here is 1.25 and 0. But you do it the exact same way. Okay, for the next one, for this one, it's a little bit different because instead of adding like we did back here, there's a hole cut out, so we're going to have to subtract. So let's pretend this whole square here has a mass of M. It's related to its area. Or how about I think this is 2 meters. So it says, actually it tells us the mass. It says 4 kilograms. A uniform plate has a mass of 4 kilograms. So we can pretend 1 kilogram is right here in the middle. And if this was a whole square here would be right in the middle, whole square here would be right in the middle, and whole square here is right in the middle. We have to pick some place for the origin, so I guess we could pick right there. So if I wanted to figure out the x center mass for this, I would do, let's call this A, B, C, and D. It would be the mass of A times its x position plus the mass of B times its x position plus the mass of C times its x position plus the mass of D times its x position. And if I were to divide this then by the total mass of 4, I would end up getting 0 for this because this x position here is a negative, let's see, this would be 1, so it's a negative 1/2. And this one is also a negative 1/2, and this is a positive 1/2, and that's a positive 1/2 right there for the x. But the problem is we've cut out this hole here, and so that's going to end up shifting it this direction a little bit. I hope that you see that the y component is going to be right along here because that circle is cut right here. So I don't really need to find the y at all. So what I'm going to have to do is I'm going to have to subtract out this mass of this circle. So I think I'm going to call that the mass E, I guess. A, B, C, D, E, yes. Mass of E. Mass of E times its, where its position is, which is right there, which is, I think that's at 1/2. So XE. Divided by, so the mass of this, A, B, C, D, that would be 4 kilograms, minus is the mass of that circle, ME, because we cut it out. And so how would we figure out the mass of that circle? Well, I hope that you see it's related to the area. So in other words, an area that's 1 by 1 has exactly 1 kilogram. So if the area is equal to 1 square meter, that has a mass of 1 kilogram. Well, we need to find out the area of the circle then, because that's going to tell me how much mass it is. And the area of that circle would be pi r squared, which is 0.25. Okay, so that area is directly related to the mass. And so we'll be able to figure out the mass and plug it in. That's how much is being subtracted out. Okay, for this last one, it's kind of a similar idea. So I think what I would do is one or two things. Either you can cut this up into 3 squares, and it says it's a uniform mass distribution, so you could just say this has a mass of M, and M, or 1 kilogram, 1 kilogram, 1 kilogram. Figure out this one's right in the center since it's uniform, so you could figure out its coordinates. So that would be up an A, half an A, so that has a y coordinate of 1.5A and a x coordinate of 0.5A. And you could do it for this one and this one. Or alternatively, what you could do is instead of doing that, where there's 3 little squares, you could pretend this is one big square and do it similar to this one, where we subtract out a square. And you need to figure out both the x and the y coordinate for this center mass.